Floating in open space, you would not explode. You would not freeze instantly. For about 15 seconds, you would remain conscious, looking out at the most beautiful view any human has ever seen. Then the oxygen in your blood would run out, and what comes next depends entirely on where you are. Mars. On a summer afternoon near the Martian equator, the temperature can climb to 68 degrees Fahrenheit. Standing on the surface, you might almost feel comfortable. The landscape is rust red and vast, stretched flat toward mountains older than any on Earth. For one moment, it looks like a place a person could belong, but the air is 95% carbon dioxide. One breath without your helmet and you would lose consciousness in under 60 seconds. The atmospheric pressure is less than 1% of Earth's, so the moment your suit fails, the moisture on the surface of your eyes and mouth begins to evaporate. Nitrogen dissolved in your blood starts forming bubbles, a condition called ebulism. Your tissues swell, your circulation slows. Radiation from the sun strikes your skin at 40 to 50 times the dose you would receive on Earth, enough to begin breaking apart DNA strands within hours. NASA Opportunity rover operated on Martian solar panels for 15 years before a dust storm in 2018 buried its panels completely. Power failed. Heating failed. The rover's last transmission was received on June 10, 2018. For a human in the same storm, with no heating and temperatures dropping to minus 200 degrees Fahrenheit at night, the timeline would be measured in hours, not years. And Mars is the most forgiving thing on this list. The Moon. The Moon sits only 240,000 miles away. Astronauts have walked on it, 12 of them. Photographs show boot prints still preserved in the dust, undisturbed after 50 years because there is no wind to move them. That stillness feels almost peaceful. But that dust is the problem. Billions of years of micrometeorite impacts have ground the lunar surface into a powder of microscopic glass shards. Unlike sand on Earth, which is smoothed by water and wind, lunar dust has never been worn down. The particles are jagged at the microscopic level, and they carry an electrostatic charge that makes them cling to every surface they touch: your visor, your gloves, the joints of your suit. During Apollo 17 in 1972, just 3 days of moonwalks were enough to nearly seize the suit joints of Harrison Schmitt and Eugene Cernan. The astronauts reported the dust smelled like spent gunpowder when they brought it inside the habitat. Breathed in over time, the particles lodge in lung tissue and cause scarring similar to silicosis, a slow loss of the ability to take in oxygen. There is no treatment once the damage begins. The Moon would not kill you fast. It would take your lungs, slowly, one breath at a time. Titan. Saturn's largest moon has a thick atmosphere, clouds, rain, rivers, and lakes with defined shorelines. The atmospheric pressure is 1.5 times what you feel at sea level on Earth, which means you could walk on the surface without a pressurized suit. From a distance, Titan looks more like Earth than anywhere else in the solar system, but the temperature sits at minus 290 degrees Fahrenheit. The rain is liquid methane. The lakes and rivers are filled with it. Methane at those temperatures behaves the way water does here. It flows, it pools, it evaporates, but it is half the density of water. If you stepped into one of Titan's methane lakes, you would not float. You would sink immediately, and the cold would seize your muscles within seconds. The thick orange haze in the atmosphere blocks all sunlight, so you cannot see the sky, Saturn, or any horizon above you. You would drown in the dark. NASA Huygens probe, released by the Cassini spacecraft, descended through Titan's atmosphere in January 2005 and transmitted data for 72 minutes after landing. It recorded wind speeds, methane rain, and a landscape of rounded ice pebbles shaped by flowing liquid. It was the farthest soft landing ever achieved by a human-made object. The probe went silent shortly after. The cold and pressure saw to that. Enceladus. Enceladus is one of Saturn's moons, only 314 miles across, small enough to fit inside the state of Texas. The surface is smooth white ice, and from orbit it almost glows. Scientists believe there is a liquid water ocean beneath the ice, kept warm by tidal heating from Saturn's gravity. For a moment, it sounds like somewhere life might exist. But Saturn's gravity squeezes and flexes this small moon constantly, cracking the ice near the South Pole and driving geysers of water vapor and ice particles hundreds of miles into space. Those geysers contain hydrogen cyanide, the same compound used in execution chambers. A direct hit from a geyser plume would expose you to cyanide gas. Death would follow within 60 seconds. If the gas did not reach you first, the eruption of freezing material would encase you in ice almost instantly, and the same weak gravity that sends geyser material into Saturn's rings would send your frozen body drifting there as well. NASA Cassini spacecraft flew directly through an Enceladus plume in 2008 and detected organic molecules, salts, and hydrogen evidence of hydrothermal activity on the ocean floor. It was one of the most significant discoveries in planetary science. For a human being standing in that same plume, the discovery would last about 1 minute. Europa. Europa is Jupiter's ice-covered moon, roughly the size of Earth's moon. The surface is a cracked shell of ice 10 to 15 miles thick, and beneath it sits a saltwater ocean that could be 60 miles deep, more liquid water than exists on all of Earth's surface. Astrobiologists consider it one of the most likely places in the solar system to harbor life. But Europa sits inside Jupiter's radiation belts. The magnetic field traps high-energy particles and focuses them directly onto the moon's surface. The radiation dose at the surface is approximately 5,400 millisieverts per day. A lethal dose for a human is 8,000 millisieverts total. You would absorb enough radiation to kill you within 2 days, with symptoms beginning in hours: nausea, disorientation, vomiting, as your white blood cells begin to collapse. If you somehow survive the radiation and one of the surface cracks open beneath you, you would fall into a black ocean with no way to determine which direction is up. The ice above you would be miles thick. No radio signal penetrates that much ice. No rescue vehicle exists that could drill through it in time. In water near freezing, you would remain conscious for 3 to 5 minutes before drowning. Your body would never be recovered, and you would have contaminated the only other ocean in the solar system that might be alive. Io. Io is Jupiter's innermost large moon, roughly the size of Earth's moon. And from space, it looks almost festive, a mottled surface of yellow, orange, red, and white from sulfur compounds deposited by volcanic eruptions. It is the most geologically active object in the solar system, with over 400 active volcanoes confirmed across its surface. But Jupiter's gravity constantly warps and squeezes Io, deforming its surface by as much as 330 feet with every 42-hour orbit. That flexing cracks the ground without warning. Lava temperatures reach 3,000 degrees Fahrenheit, hotter than any volcano on modern Earth. Eruption plumes launch sulfur dioxide hundreds of miles into space. The compounds would eat through a standard spacesuit on contact, beginning with the seals. Io sits inside Jupiter's radiation belts. The surface dose is approximately 5 times the lethal radiation amount for a human delivered every 24 hours. NASA Galileo spacecraft made multiple flybys of Io between 1999 and 2002 and recorded volcanic eruptions in real time, including one plume 300 miles high. Galileo's electronics were progressively damaged by radiation with each pass. It was eventually directed into Jupiter's atmosphere to prevent contaminating Io. The radiation that destroyed a hardened spacecraft's instruments would reach your organs far faster. Saturn. Saturn is the second largest planet in the solar system, ringed and golden and photographed on the walls of classrooms everywhere. The rings look almost decorative from a distance, a flat disk of ice and rock glowing in the sun. But those rings are billions of individual chunks of ice and rock, some the size of grains of sand, others the size of houses, all moving at up to 45,000 miles per hour. Any one of them striking your ship would destroy it completely. If you made it through, Saturn's upper atmosphere sits at minus 418 degrees Fahrenheit. As you descend, the winds accelerate to 1,100 miles per hour, 5 times the strongest hurricanes ever recorded on Earth. Your craft would lose all directional control within minutes. Below that, the gas thickens under pressure until it becomes liquid. NASA Cassini spacecraft spent 13 years studying Saturn before being directed into the atmosphere in September 2017 to prevent contaminating the moons. It was destroyed in minutes. No solid surface ever came to stop it. The same fate would find you, not an impact, not a crash, just a slow compression into nothing as the atmosphere grew thicker and hotter and finally reached 21,000 degrees Fahrenheit at the core. HD 189733b. HD 189733b is a gas giant 64 light-years from Earth, slightly larger than Jupiter, and from a distance it is a vivid, deep blue, almost exactly the color of Earth as seen from space. That blue looks like oceans. It looks like home. But the color comes from silicate particles suspended in the atmosphere, tiny shards of glass formed. When rock vaporizes in 1700 Fahrenheit heat on the day side and then cools and hardens as it rises, those glass particles are caught in winds moving at 5,400 miles per hour, approximately 7 times the speed of sound. They do not fall downward like rain. They fly sideways at over a mile per second, circling the entire planet continuously. At that velocity, a single glass particle smaller than a grain of sand carries enough kinetic energy to penetrate a standard spacesuit. A full exposure would last less than 1 second. The particles would pass through your suit, through your skin, and through the tissue beneath before you registered any sensation at all. There is no sheltered side of the planet. The winds encircle it completely. There is no solid surface to land on. There is nowhere to go and no time to get there. The Hubble Space Telescope confirmed HD 189733b's blue color and glass rain in 2013, using spectroscopic analysis of starlight passing through its atmosphere during transit. It remains one of the most studied exoplanets in existence. It is also one of the least survivable square inches of space ever identified. A supernova, a massive star in its final hours, still burns. It is still a star, still fusing, still radiating, still the center of its own solar system. For millions of years, it has simply existed, unremarkable in the sky. Then, in seconds, it releases more energy than our sun will produce across its entire 10 billion-year lifetime. The outer layers of the star collapse inward and then rebound outward in a shockwave moving at 25,000 miles per second. Ahead of it, traveling at the speed of light, comes a burst of gamma rays and X-rays carrying enough energy to strip electrons from atoms. Because that radiation moves at the speed of light, there is no warning. By the time your instruments detected the burst, it would already be passing through your body. Within a few light years of the explosion, the radiation breaks apart every atom in your body faster than any nerve signal can travel. You would not feel it. You would simply stop existing in any coherent form. At distances up to 50 light years, a supernova can strip a planet's ozone layer and flood the surface with lethal radiation for decades. Some researchers, including Adrian Mellett at the University of Kansas, have proposed that a supernova approximately 65 light-years from Earth around 450 million years ago contributed to the late Ordovician mass extinction, which eliminated roughly 85% of all marine species. It killed from 65 light-years away. Distance is not the protection it appears to be. Jupiter. Jupiter is the largest planet in the solar system, 89,000 miles across. Large enough to contain every other planet combined with room remaining. Its cloud bands are beautiful from a distance, rust and cream and white, swirling in patterns that have persisted for centuries. The Great Red Spot alone is a storm larger than Earth that has been observed continuously since 1831. But Jupiter's magnetic field is 20,000 times stronger than Earth's, and it traps radiation so efficiently that the lethal dose begins accumulating 186,000 miles from the planet's surface before you have even entered the atmosphere. Your electronics fail first. Navigation, life support monitoring, communications, all of it stops within hours. Then your bone marrow begins to fail, because the high-energy particles are passing through you continuously, disrupting cell division at the chromosomal level. If you somehow reach the atmosphere, winds of 400 miles per hour and lightning bolts wider than Earth would tear apart any craft. NASA Galileo atmospheric probe entered Jupiter's atmosphere in December 1995 and survived for 58 minutes before the pressure and heat destroyed it at a depth of approximately 87 miles. It never reached the liquid hydrogen layer below. The pressure that crushed a hardened scientific instrument in under an hour would reach your suit long before that depth. You would be compressed slowly, from the outside in, with nowhere left to fall. A black hole. Stellar mass black holes form when massive stars collapse. They are not visible, no light escapes the event horizon, but they can be detected by the effect of their gravity on surrounding matter. From a safe distance, a black hole is invisible. It looks like nothing. It looks like empty space. The problem is that gravity does not pull evenly across a body. The difference between the gravitational pull on your feet and the gravitational pull on your head, as you approach the event horizon, increases exponentially. Your spine would begin to stretch. The force pulling your lower body would separate your vertebrae one by one before tearing through the muscles of your torso. Physicists call this process spaghettification. Your body would elongate into a thin stream of particles spiraling inward. For an observer watching from a safe distance, something strange would happen. Due to gravitational time dilation confirmed by every precision clock experiment conducted since 1971, time near the event horizon slows relative to time far from it. Your image would appear to freeze at the horizon, gradually red shifting from visible light to infrared to radio waves, fading but never fully disappearing. You would be gone. To the universe, you would appear to still be there, suspended at the edge of everything, forever. A magnetar. A magnetar is what remains when certain massive stars explode. The core collapses into a neutron star, only 12 miles across, but so dense that a single teaspoon of its material would weigh 5 billion tons. Its magnetic field reaches 1 quadrillion times the strength of Earth's, the most powerful magnetic force known to exist anywhere in the universe. From 600 miles away, the field begins reshaping your atoms. Electrons are forced into elongated orbits. The normally spherical atoms in your body are compressed into thin, needle-like structures. The molecular bonds holding your proteins together, the bonds that keep your cells intact, that keep your DNA coiled correctly, that keep every biological process running, stop functioning. Your body does not burn. It does not freeze. It does not explode. It simply comes apart at the molecular level, in silence, with nothing visibly touching you. In December 2004, the Magnetar SGR-1 8Ti SGR-1 8T06-20 released a burst of energy that measurably ionized Earth's upper atmosphere from 50,000 light-years away. A single half-second pulse from across the galaxy left a detectable mark on our planet's ionosphere. Paul Woods at the Marshall Space Flight Center described it as the most powerful cosmic event ever observed affecting Earth. If you were within a few hundred miles of the source when it fired, there would be no body left to find. There would be no record that you had ever been there at all. Space does not hate you. It simply has no category for you. Every rule it follows was written before life existed, and not one of them was written with survival in mind. If you'd like to see more videos like this, make sure to subscribe and feel free to drop suggestions for the next video in the comments.